Good morning, everybody. Now that we understand what measuring is, we're going to focus on a few quantities that we can measure and find out what they are useful for. The first quantity we're going to be looking at today is volume. Okay, and since volume starts with a capital V is what's used to represent volume in formulas or equations. And volume is the amount of space occupied by a substance. All right, so you could have the volume of a liquid, a gallon of milk. The volume of the milk inside is 1 gallon. You could have the volume of a solid. A cube has a volume, takes up the space called a volume. It's just cube shaped and it can't change shape like the volume of a liquid can. Now the SI units for volume, there's two. One is milliliters and the other is cubic centimeters. You could also use cubic meters in SI as well if you're measuring very big things. Now, why two different units? Why milliliters and centimeters cubed? Well, that's because we have two different types of substances we can measure. If we're measuring solid volumes like cubes and spheres and other even irregular shapes, we use centimeters cubed. Meters cubed if they're large. Liquids, we use milliliters, or if it's a large amount of liquid, liters. Now, an interesting thing about liquids, and this is not true for solids, it's only true for liquids. Typically, 1 milliliter of a liquid is equivalent to 1 cubic centimeter of the liquid. Now that's not true for solids, it's only true for liquids. So, suppose you are a nurse and you're told to give a patient 15 milliliters of a liquid pain medication, but the syringe that you're going to pull the pain medication into from the vial has a scale that's in cubic centimeters, or sometimes they'll call it cc's, cubic centimeters. What measure in the syringe would be 15 milliliters that you need to give the patient? Well, since the medicine is a liquid, you need to write this down. Since the medicine is a liquid, the nurse would pull 15 cubic centimeters, that is 15 cc's, into the syringe. Because for a liquid, which is what the medicine is, 15 milliliters would be equivalent to 15 cubic centimeters. Okay? And I'm sorry about the shadow on the paper. I've tried to orient this to get rid of it, but I just can't seem to find a way to do that because of my lighting. So I apologize for that, but it's not much of the page, so I think we can work around it. Okay, now look at the next example. Instead of looking at a liquid, now we're going to look at a solid. They want to know what is the volume of a box that is 25 centimeters long, 20 centimeters tall, and 15 centimeters high. Now we're not talking about a liquid, we're talking about a solid. So, whenever you're looking for the volume of a solid, especially a solid that is a regular shape, like a rectangle or a cube, we have a formula for finding the volume. Do you remember what it is? I would hope so, because it's not terribly difficult. Okay, so for a rectangular solid like this, we would use length times width times height. Okay? So here we know the length, the width, and the height. So we're going to say 25 centimeters times 20 centimeters, and then times the 15 centimeters. All three dimensions of the box. All right, now to get the volume, you multiply the three numbers together. If you do that on your calculator, you can check. You should get 7,500. Now the units, centimeter times centimeter would be centimeter squared. But we've got to multiply by another one. So that's going to be centimeters cubed, which is the correct unit for volume of a solid. So the answer would be 7,500 cubic centimeters for this particular box. Okay? Now, we might need some common formulas for volumes of regular solids. So let's look at a couple. Well, just as we said a moment ago, for the rectangular solid or a cube, a rectangular solid or cube, the volume is length times width times height. But what if you have a sphere instead of a cube or a rectangular solid? Well, the formula for that is 4/3 times pi. Because it is a sphere, it means it's related to circles, so you have to have pi in there, times the radius cubed. And that's where the centimeter cubed will come in, because the radius is measured in centimeters. Now, what about pi? All right, well, if you remember from math, pi is the diameter divided by the radius, and it always has, for any spherical or circular object, it always has a value of 3.14. Actually, yada, 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 yada. But really, all we need is the 3.14. Okay? And r is the radius. And if you remember, a radius is from the center out to the edge. Diameter is all the way across through the center. But the radius is half that. It's from the center to the edge. Okay, so those might come in handy. So keep those in mind. We'll probably be using them in a practice assignment tomorrow. Now, we want to know, why doesn't the liquid equivalency work for solids? Remember our liquid equivalency? We said 1 millimeter of a liquid is the same as 1 cubic centimeter of the liquid. Why doesn't that work for solids? Well, it works for liquids because most all liquids have the same number of atoms or molecules for the volume of space. But solids can be very, very different. In other words, they can have different densities. All right, so why doesn't the liquid equivalency work for solids? Because solids can have very different densities from each other. Liquids have very similar densities, so it works for them. But solids can have very different densities. Okay? Now, let's talk about density and see what it is. First, we need some definitions so we understand what we're talking about. Whenever we talk about density, first we have to understand that all these substances are made up of matter. Remember, any matter is any quantity that has the properties of volume, that's one property, mass, there's another property, inertia, and gravity. So matter always has four properties. You're made up of matter. You have all four of these properties. Today, we're concerned with these two, volume and mass. Volume, as we said up at the top, is the amount of space that your chunk of matter takes up. What is mass, however? Well, mass is simply the amount of matter in a sample, okay? We do use in formulas a lowercase m to represent mass of a substance. Capital V for volume, lowercase m for mass. Now, when we measure mass, it's measured in grams if you're measuring small items, or kilograms if you're measuring large items in System International, okay, in SI. Now, we know what mass is and we know what volume is. If we talk about how much matter is crammed into a certain volume, we're talking about the density. The more mass you have, the more mass you have stuffed into a particular volume, the denser it is. So look over here. I'm going to do a couple little drawings right here. Let's say we have two identical volumes, and I'm going to represent them with just a two-dimensional square instead of a three-dimensional picture. We don't really need 3 dimensions right now. We'll just look at 2. All right, let's assume these are two identical spaces. All right, so if we look at the amount of matter in each space, in fact, let's give them a volume. Let's say this is 1 cubic centimeter, and this is 1 cubic centimeter. Now let's look at the amount of matter inside. Let's suppose that in this one, this is the amount of matter inside. These dots represent molecules and atoms. Now let's look at this cube. Let's say that in this cube we have these atoms and molecules. Starting to see the difference? So this one, because it has more particles, more atoms and molecules per volume than this one does, this has a greater density. It's denser, okay? So the more mass you have for the same volume, the more density the object has. All right, so let's define density for certain now. Density. And guess what letter we use in formulas to represent density? Yep, you got it, a capital D. All right. The mass per unit volume of a quantity of matter. Mass per unit volume. Now, where have you heard per before? Meters per second, miles per hour. Per is simply a shortcut term for a mathematical operation. Now, we'll talk about which one in a moment, but I want you to think about it and see if you can guess which one. So, density being the mass per unit volume of a quantity of matter. In other words, how closely packed together the atoms or molecules are. And the units for density are grams per milliliter if you're talking about a liquid, or grams per cubic centimeter if it's a solid, and this is for the small stuff, okay? Because grams and milliliters, grams and cubic centimeters, those are small. What if you're working with large items? Well, then it would be kilograms per liter cubed or kilograms per meter cubed. Okay, so this is for the small, and these are for the big. Nope, there goes my clock. Sorry about that. All right, so now we know the units. Big ones, like say cars or buildings, big items. These are small, like marbles and little metal cubes. In fact, we'll see some little metal cubes before too long. So how do we use a formula to find the density of a material? Well, here's where that per comes in. It says mass per unit volume. Per indicates that you're going to divide, all right? Kilometers per hour, you're dividing kilometers and hours. Meters per second, you're dividing meters by seconds. So mass per unit volume, you're dividing mass by its volume. So we're going to say mass over or divide by the volume. And that's how you get the units. Grams, milliliters or cubic centimeters, kilograms, and cubic liters or cubic meters. Okay? One divided by the other, per. Okay, this is what we're going to be using to determine density. Now, how can you remember that it's M over V? Sometimes people get confused and they switch them. They'll put the V over the M. So how can we remember? Well, I learned this a long time ago and I thought it was really very helpful. Okay, so density is at the heart of the matter. Now, what do I mean by that? Oh, watch. What do you get? You get a heart. So, mass over volume. Get it? That's one way you can remember that mass always goes on top and volume on bottom because it makes a heart. Now, let's look at this little example. And if you have a calculator, you'll want to do this with me so that you can check and see that you get it right on the calculator also. We want to find the density of a small block that has a mass of 17 grams and a volume of 3 centimeters cubed. So, let's identify what we're given. 17 grams. As you know, grams is a measure of mass. 3 cubic centimeters. Cubic centimeters is a measure of volume. So now we've identified the given information. To find the density, we need to use our formula, so we first write it down. Always write down the formula you're going to use first. Don't you start plugging in numbers before you write that formula down. That's a no-no. All right, so mass on top, volume on bottom. Now you take your calculator and say 17 divided by 3. If you do that properly, you should get 5.7. And what are the units? Oh, grams per centimeter cubed. The units always come from whatever's right here. Okay? So grams per centimeter cubed. And there's your answer. That's the density of that particular item. 5.7 grams of matter, grams of molecules and atoms for every cubic centimeter of the material. Okay? Now, because the units of density are made up of a combination of SI units. Notice it's not just one SI unit, it's 2 of them used in combination. Any substance that has units that are SI units used in combination like this, it's not a single SI unit by itself, but it's a combination. Those units are called derived units. Now, density is not the only substance with derived units. In other words, they're derived from the formula. A Newton of force. Force is measured in a unit called the Newton. And 1 Newton equals 1 kilogram meter per second squared. So as you can see, the Newton is a derived unit because it's not one SI single unit, it's a combination of SI units. So it's derived, okay? Acceleration. Acceleration uses units of meters per second squared. So those are derived units. They come from the formula. Okay, so density has derived units. Okay, that's all there is for today. I hope you've learned something from this. We are going to be practicing using this over the next few days. It's going to be kind of fun. We're even going to do an online lab. I hope you'll like it. And we'll learn about a guy named Archimedes as well. Because one thing we haven't talked about today is how to measure volume if you have an irregularly shaped object for which you don't have a formula. Okay, it's not a liquid, it's a solid, and it has no regular shape, and therefore no formula exists for it. How would you find its volume so you can get the density of the substance? That's an interesting little trick we're going to learn about this week. Okay, stay tuned. Bye-bye.